ANMAtalks is an initiative for sharing knowledge between students, staff and management of the Nordic and Baltic Academies for Higher Music Education and anyone else interested. Welcome to this 9th edition of ANMAtalks, where we have invited Thor Madsen from the Danish National Academy of Music to share his artistic research project, Performance Machine. Thor, welcome to you. Thank you so much for doing this, and the floor is yours.
Thank you, and thank you for everybody who's participating from around the world. So about a year ago, I got funding for this project that initially was called Performance Machine. And the idea was to make as an app in a program called Super Collider, which takes a performance by a performer in the form of a MIDI role, you could say, and create an augmented performance based on the initial input. And I'll get into more details about exactly how it works. There are two kinds of events, as I call it, in the program: modulator events and generator events. And modulator events, they affect the sound. They modulate the sound by use of LFOs and effects, and generator events create events like playing a chord or sequencing a bass line, playing a rhythm, stuff like that. So right now the program has a pretty extensive user interface. You will see examples of that later. And right now it requires installation of Super Collider. I'll get back to what Super Collider is in a second. But the aim is to create a standalone app that will work at least on a Macintosh computer in OS X, possibly on Windows and Linux too. And as I said, the app is MIDI based, but it also has like some special features that require what you can call synchronized audio and video. And what I mean by synchronized audio and video is that incoming audio matches the MIDI at the same time. This I achieved by using a third-party plugin called MIDI Guitar, because I'm a guitar player, so I'm intended on using this app for guitar. So MIDI Guitar from Jam Origin translate the incoming audio in real time to MIDI without the use of a special MIDI pickup. It's simply based on the incoming guitar signal. It doesn't have to be that program. It can be any program that converts audio to MIDI in real time. I'll also get back to the problems about converting audio to MIDI signals, which is not a trivial thing, to say the least. But most of the functionality of the app can be achieved with just MIDI, so simply playing a MIDI keyboard. All right, so I just briefly explained what the program is, and again we'll get back to some examples of how it sounds and how it works. But before that, I will just talk a little bit about why I decided to do this. And actually I realized that this has been a thing developing over many years in my head, in my mind, this desire to create a program like this. And it comes from, I think, two distinct desires. One was to participate in what can be called generative music. I grew up listening a lot to Brian Eno and this sort of like ambient landscapes of music, and I was always really fascinated by it, and also I felt an urge to participate. And what I mean by participate is not just play over the music, but play into the music, play inside the music and affect what's going on by what I play. That was a pretty abstract idea, to say the least. The other idea was the idea of shaping a sound directly by my playing. I remember watching a James Bond movie many years ago where they were sort of like treating visual objects. You've seen a lot of like TV series like this where they have some sort of fancy way of modulating images in the air or something like that. So a similar idea of using my guitar to affect the sound of something else was the other desire. And a sort of like a primitive way or a first step of modulating sound by your playing can be done by gating. I mean, there are whole genres built around the concept of gating. A lot of the EDM genres have like this thing where the kick drum gates or compresses everything else, so everything is like sort of like in sync with the kick drum. I did similar experiments with guitar and gating. So you could say gating is a very primitive way of making your input affect an output. But that wasn't enough for me, so I decided to see if I could actually make a program that was a little closer to what I imagined. I had been dealing a little bit with Max MSP. I guess some of you probably either tried it or heard of it. Max MSP is a programming language that caters especially to music and sound. And I got a little fed up with Max MSP. I think it just has to do with workflow, and they tons of cables, like virtual cables you have to drag around. And so when I found Super Collider, which is a similar program, I was very happy. Super Collider is strictly text-based. It's just lines of code. There's no user interface other than a text editor, and there's no drag and drop. The lack of drag and drop was quite a challenge when it came to designing a user interface. I won't go into details about that, but just to say that that was somewhat of a task. So when I sent my application to do this project, I had just been watching videos in Super Collider, like tutorial videos, and programmed a little bit for like 3 weeks, basically. And I sort of like half lied about how proficient I was in Super Collider. But I thought I knew enough to see that this app was possible. So I just went ahead and started the only way I know, trial and error. I guess that's the way I've been approaching everything. Instead of trying to learn everything beforehand, then learning by doing, learning by actually trying to create meaningful stuff and then learning along the way. Initially, I watched a lot of videos by Eli Fieldsteel, who is a big expert in this language and other languages as well. And he is with the University of Chicago. So I contacted him in the beginning of the process and asked him if he would act as an advisor for the project. So he helped me, not so much specifically with the whole code, but more like parts of it and how to approach certain issues I had. There are a lot of issues when trying to create something that works in real time. There are a lot of issues when trying to create something that does not work in real time in a programming language like Super Collider. But add on top of that I needed this to happen real time. I couldn't really find anybody else who had done anything that was close to what I did. So again, I just ventured ahead and tried to make it as good as I could. I have been using technology in music for many years, and I was probably one of the first people in the world to bring a laptop on stage. I remember an article when I lived in New York and we were touring. I remember an article sort of like ridiculing me for bringing a laptop on stage, saying, was I checking my email? And we're all the way back to the early, maybe this was 2001 or 2 or something, the very first titanium MacBook Pro came out, and I bought it and I dragged it on stage, and I probably did all the mistakes you can possibly do when trying to incorporate technology on stage. The first issue being, being way too ambitious with what you can actually what you can actually do in an online, in a performance situation, giving myself too many options. And then over the years, I learned to sort of like restrict my options a little bit. But still, I had some basic issues with using technology on stage. The first issue is like, why does the computer never follow me? Why do I have to slave myself to the computer at all times? And that's been driving me nuts. I love the technology. I love the sounds I can get out of technology, but I just really don't like the idea of giving up my sense of timing and sort of like my part of my musicality and just hand it over to a computer. There's a lot of like genres based totally on computers that I love to listen to. It's not an issue of production really. It's more of like the performance situation where I got frustrated. So that was another goal of mine, to make a program that actually followed me, that rather than me following it. And I wanted to free my hands, because like I've tried all kinds of setups where you have, as a guitar player, playing guitar using foot controllers, like using one hand or the other hand to turn a knob on a controller. And first of all, I only got two hands, so that's a problem. But also the way that one brain is like thinking about music and the other brain is thinking about technology, I think is a challenge. It's something you can definitely practice and get better at, but it's always a challenge. And I always found that I used too much of my attention on stage thinking about technology and not thinking about music. Okay, so I'll go into a little more detail about the application and the software. There's a concept that I was actually pretty recently exposed to called sonification of data. And again, I was new in this field. Many of you probably heard of this before. But sonification of data is a way of sonifying, meaning making sound or music out of a data set. And often when we talk about sonification, we're talking about data sets that comes from outside music. One very famous example is tracking fish in an aquarium and connecting the movements of fish to certain musical elements. So you could say that my idea was taking a data set that actually comes from music and sonify it. And the data set in this case is MIDI information in the form that you would see in most DAWs. Like if you record MIDI into Logic and you see the roll of MIDI events, it's just like MIDI is basically a piano roll. MIDI is just a modern example of a piano roll, like punching holes in a paper, putting it through piano. Every hole corresponds to a note that comes out at a certain time and ends at a certain time. MIDI has capabilities a little bit beyond that, but not much actually. So I took the piano roll in the form of a collected MIDI list, and then I treated that information as a data set that I could re-sonify. You could say that mostly when we use MIDI with Logic or Pro Tools or anything like that, we have a pretty standard way of translating MIDI events. We have on the sending side, in Logic you could say that they're both in the same program. But if you think of it conceptually, you have like the MIDI information, and then you have the way that that MIDI information is translated into music. The MIDI information doesn't say much about how it's going to sound, because it depends on what synth or what receiving device you have on the other end. But usually we just use it for like whenever a note plays, that note plays on the receiving end with whatever sound source is connected. But what I wanted to do was collect the MIDI information and then do some calculations on it, and to tell something more meaningful about the performance than just a note was played. So what can that information be? Well, we can examine if a phrase was played like a crescendo or a decrescendo. We can see if it's accelerating or the opposite way, if it's slowing down. We can say something about whether a pattern has been repeated, like a repeat pattern in this context means notes being repeated, not necessarily the same rhythm. We can say something about how much variation the player plays with, meaning does the player reuse the same notes or play a lot of different notes? We can examine what I call scalar content of the playing. Like simply, is this inside a specific scale? We can also examine scalar content of something that's already going on in the program with what's being played, and derive chords from scales being used. So I took all this information I could derive from the MIDI roll and attached it to meaning. So you could say I created an artificial language translating gestures or features of the playing into actions. And it's important for me to emphasize that the language I invented can be changed at any point. I don't have any desire to be objective or truthful. My only desire is to create interesting musical responses that I as a performer can feed off, to create a feedback loop between the responses I'm served back based on my own playing and my immediate own playing at the same time. So in this way, I think this sets my approach apart from a lot of other approaches I've seen, is that what you play is simultaneously a part of the performance and a trigger for the augmented performance. So if you think about it, if you use a controller with a button to trigger something, then you can get the result of the trigger, but the action of pressing the button is not part of the music. If you're in Ableton Live, you fire a clip, well, visually, maybe your button touch is part of the music, but musically it's not. It doesn't give out a sound, it doesn't do anything, it just triggers the next event. But here we have a different situation, because everything is simultaneously a trigger and a performance. So this is also a little bit of a challenge when you perform, because you can want different actions to happen, but the way you make them happen is by what you play. If you just aimlessly go for triggering certain actions, then you might hurt your own performance. So you have to balance this, what you play with what you are fed back from the system at all times. And this is the feedback loop I was referring to. All right, I think it's time to see a little bit about what's going on here. There are like 4 or 5 major sections of the program. The mother of the program is the drone playing, and in essence, the drone is just like, it has the same feature as a latch button on a keyboard. You play a note, and you can make that note go on forever by holding it or latching it. And in this language, it's done by simply playing the first note in a scene, and a scene is a collection of possibilities at a certain time. And then after the drone is set, you can move it by playing the same note again, followed by a new note, and you can stop it by playing the drone note 3 times. So it's pretty basic. And let's just watch a video, and I'll play some stuff later where I use guitar, but for the first example, I will play an example where I'm using a MIDI keyboard. So, as you might have noticed, the sound of both the drone and the play synth, which is the one that echoes the input, changes during the performance. None of the changes are pre-programmed, and none of the changes happened by me doing anything other than inputting MIDI notes. So all you heard there was came from just analyzing incoming MIDI. Maybe you notice when playing chromatically for more than 2 notes, that triggers the vibrato of the drone synth or the bass synth. And playing a repeated pattern moves the filter cutoff frequency of the bass synth either up or down depending on the nature of the repeat phrase. And then there's a lot of other modulators. There were 12 or actually 6 pairs of modulators present on the bass synth, and 4 sets of modulators present on the play synth, plus 4 effects on each. Each of these modulators or effects has rules that define when they play or when they don't play. And we can just let's just look at what rules are here. So the blue thing here is analyzing MIDI data, and that happens on every incoming note. So every note on message will trigger a range of calculations that result in different values being produced. So one simple value could be the average loudness of the last 5 notes. Another one could be, it could be a Boolean condition, as we call it, saying if it was a crescendo, all the things I talked about before. And these values are used in 2 different ways. They're used to test if some event should happen. So to test a simple value, we could say, okay, if the loudness, or if the amplitude, I should say, if the amplitude of the last 5 notes is greater than a certain threshold value, do something. And this is relating to what I'm showing here. This would be value 1. Then when the do something is true, 2 other values can be used to set the actual event. So let's say, again, going back to amplitude, if amplitude is greater than this and this, affect this modulator, but use two other values to affect it, and map the value of one of them to the amount of modulation, and map the value of another value to the rate of modulation. So this is a simple example of a modulator event. Generator events that actually play sound, like setting a drone or playing a chord or starting a rhythm, have a similar structure, but they can be a little more complex. All right, so let's look into what the audio side of this program can do. So again, you can use the program just as MIDI, but some of the fun comes from actually using audio input. So let's play one here. Find the right one.
So before you press play, just so you know, I think you should stop sharing your screen and sharing it again, because right now, at least to me, it looks a bit strange. So
okay, well we'll see if let's just redo this.
What you showed before was fine, but
okay. Yeah, we can look at. Let me see. Let's try this one. And before we play I play this one, I'll just say that the user interface, you see there's a little dot right here showing where the root is. There's some problem with the interface when using guitar, and false triggers happens, which means that you see two dots at some point. That's not intentional, I should say.
So now it's moving around for us as well.
And we'll check another one here where a little more different stuff is going on. Yeah. So again, everything that happened here was due to the performance. Nothing was changed with controllers or anything while I performed. And there was a lot of, this is a pretty complex scene with a lot of different options, so a lot of different things were going on here. I'll just briefly touch on some of them. Repeating a pattern of 3 or 5 or more notes will initiate a sequence. And there's no predefined tempo in the system, so the system is trying to deduce the tempo I played in, but in a more intricate way than simply tapping tempo. So I'm testing different grids within the duration of what I played to see if it matches 16th notes or any other normal note value. And in this example, we had the case of metric modulation. It's virtually impossible to decide if a pattern is conceived of as being 16th note or triplets in certain instances. I don't think a human would be able to detect it either without having somebody stomp their foot, or it can be very hard to tell whether it's one or the other. So here we had an example where I thought of it as being 16 notes, but it came back as being triplets. But the duration was right. It's just that it modulated my sense of tempo, like a standard between 3 and 4 metric modulation. It doesn't happen always that way, but that's one of the ways I can be pleasantly surprised by the program. You also heard like a ring modulator happen at certain points. The ring modulator of the bass center is set to react to a whole tone scale, any of the 2 whole tone scales relating to the current root. And there were other, and the chords happens in different, the way the chords are calculated depends on the state of the system. Sometimes they relate to what's being played in relationship to the drone playing, but if there's no drone playing, it looks at the notes of the bass line and tries to deduce scalar information from the bass line. I won't go into detail about exactly how these chords are created, but just to say that the creation of chords is one of the bigger elements of the system, and it's very dependent on what's going on at the time, how those chords are calculated. Yes, and we're running out of time, so I'll just briefly talk about how it feels to play this and how I think it can be used, and then we'll have some questions. So in a way, it's a little premature for me to say if this can be used or how this can be used in a performance, because I've been in engineering mode for a year now. And of course, I've been trying to test this system, or I've been forced to test this system while being in engineering mode, but I just find that mentally it's 2 very different spaces, exploring something from a musical standpoint and trying something to test it, to check if everything is working the way it's supposed to be. It's two different mindsets, and it's hard to be really musical when thinking about technical stuff. So that's my little disclaimer before saying how it feels to use this program. That being said, I think that the strength of this approach is the mental attachment to the result. There have been many quests to use artificial intelligence to create music. There are even some systems that can auto-generate music based on genre, and some systems you can train by playing into it, and then after you trained it, it will give you another version of yourself. I think this is all exciting and fine, but I think the pitfall of using artificial intelligence in music is the emotional detachment from the product. I suspect that future generations will have a different idea of this. But from my point of view, from somebody who grew up without technology or without this computer technology in music, that is the case. But in my system, there are 2 factors that makes it more that heightens my emotional attachment. One is simply the feeling that the program reacts to what I do, and I know the rules by which it responds to me, and so I know that everything that's happening is due to my playing, not some fancy algorithm that I don't really, something I can't really see what's going on. If you use artificial intelligence, you don't really know why it's doing what it's doing, because that's too complicated to understand. Here, this is a little more simple in a way. And so the awareness of how this is achieved and the actual feeling of how it reacts makes it, increases the mental ownership of what comes out. So, and then I think it's really fun to have something that responds to me and, I got your technology. Now you're actually reacting to me instead of me being slave to you. So I think that's being fun for me. Then I see a couple of uses that I didn't anticipate beforehand. In some situations, the creation of chords when no drone is playing and no root is defined is a great ear training exercise, because you have to, what comes out, the chords that comes out relate to what you just played, but not in a way that you can totally predict. For instance, if let's say you play the notes, let's say the last 5 notes you played are the first 5 notes of the Aeolian scale in C. Let's just say that C, D, E flat, F, and G. Well, that's also a subset of the melodic minor scale. It's also a subset of the harmonic minor scale. It could also be a different mode of the Aeolian scale. It's also a subset of the chromatic scale. So the actual scale being generated is, you don't know. So ear training, again, I think this has the same advantages of mental ownership as I talked about before. Usually ear training apps, the ones I tried at least, will feed you something not based on what you played, but will just feed you something and ask you to decipher it. Here you're fed something that you generated yourself, which is much closer to how a piano player will comp you in a, let's say, a jazz setting, where you have some framework for what the chord is, but the actual chord being played depends on what you play, if it's a good piano player at least. And then the last thing I want to touch on before taking questions is, this is an extremely easy program to play and an extremely hard program to control. It's easy to play. My 8-year-old daughter will just randomly tap the keyboard and get some sound out. And sometimes she gets some sound out I would never get out of the system, because she's just aimlessly, or what, I don't know what she's thinking. She's just playing away. Something happens. So anybody can create responses in this system, and you probably wouldn't have to play too long to trigger most of the responses in the system. Or we could randomly generate MIDI notes and we would eventually trigger all responses in the system. But controlling it is much harder. Once you start to feel that the connection between what you play and what you get out of it, you establish a connection with not another human, but with a program. And that connection is pretty similar to that of interplay between two musicians. So I think that in the long run, this kind of approach could also help show people that don't know anything about music, or maybe beginners in music, some virtues of interplay. And I think in our field, we need awareness of performance, not just from ourselves, but from everybody who is around us, from the surrounding society. We need to heighten the understanding of what interplay is. And I really think that, there's a war going on now. I think music is a peacemaker. And I think the listening part of playing music is super important. And I think that listening part can be used in other fields of society. And I think that the more we can express the beauty of the listening part of music, the better the world will be. So on these high swung words, I will I'll give it back to you, Camilla.
Thank you so much, Thor, for an amazing presentation, and also for, whoa, broadening the scale here with the last words. I think you're completely right. And I have a question for you.
Yeah.
First, I'm curious, because you've had to learn so many things to do this. Was there a point where it's kind of man against machine, isn't it? Was there a point where you were considering to throw in the towel and give up, or how did you overcome all these new things that you had to learn?
Yeah, I don't think I was about to quit, but I was really, really frustrated at time. I want to say something about the programming community. The programming community is beautiful. It's the amount of help you get from, and the way that they treat novices like me is just plain beautiful. The whole concept behind Superglider is that it's open source, and the whole open source technology, mindset really impressed me. And people can be pretty protective of their music, and how many times do you see some artists put out an album and then say, here are all my samples, all my synth presets, ask me any questions about what I did, I'll answer it, I'll send you the MIDI files. This is sort of what people in the programming community do. So I got a lot of help from asking newbie questions on these fora and getting really detailed responses back. Initially, I was just interested in creating a program for myself to perform with, but in the process, and greatly inspired by the online programming community, I decided to release this for everybody, to sort of give something back to this community.
Thank you very much. Do anyone else of you have questions for Thor? And again, you're welcome to either write in the chat or just speak out. No, doesn't seem to be the case. Well, Thor, do you have any final words that you want to share?
Now I demonstrated this, the audio part of the program. I'll just explain a little bit about what's going on here. Audio is being recorded, say, in two different buffers when I play continuously. The problem was, what if I decided to play for 2 hours? That's a long buffer. A 2-hour buffer is a really long buffer, and it's also something that can go wrong at any time. So the way I solve this is like I'm recording the last 30 seconds of what I played into 2 different buffers, but they are offset, so one starts in the middle of its cycle and one starts from the beginning of its cycle. So that way I can always access the last 15 seconds of audio from one of the 2 buffers. So everything you heard in the audio section, where chords were generated from my guitar playing and created these ambient sounds, the ones that were not based on synths, are based on notes I just recently played. So now I couldn't test it. I didn't test it with effects, but if I had chosen to play wah-wah or distortion or something, that the sound would have changed, because now my notes would have been different. Again, I think that's really exciting that everything is generated. I could have used pre-programmed or pre-prepared samples, but I think it's just so much more fun, this idea of everything that happens is generated by you in the moment. So yeah, that's just a great example of that. And maybe should we just, I guess we can see one last video as people are leaving. Is that a good idea?
Yeah, no problem. I'm also going to post a link in the chat that you can open. And I'm always struggling, for you who have been at ANMAtalks sessions more than one time. I'm always trying to come up with a new way of selling this very interesting questionnaire about how you think the session was. Today, I find myself out of ideas, but please open the link and fill out the questionnaire, and we'll be very happy about that. So just press it now before you leave the meeting. Thor, one last video.
Yeah. Oh, wait a minute, we saw that one. We'll take one we didn't see yet. We'll take this one. Yes, I think we will. We'll let that be the last sound. And just a final note that the sounds right now can be changed at any time. I mean, actually changing the sounds is much easier than changing anything else. So yeah, I chose some sound that was pretty obvious, pretty standard sounding, because I thought that would be make it easier to decipher what's going on. I could have made much more abstract, arty sounds. The concept would have been the same, but possibly harder to decipher. So that was just a design decision on my part. So thanks everybody for listening. And if you have any final questions here, just fire away.